Okay, so next I have actually 2 questions for you to go ahead and try on your own. So the first one asks, how much heat is required to heat 10.0 grams of water from 21.5 degrees Celsius to 35.6 degrees Celsius? So one thing they don't tell you with this is the specific heat of the water, but it's in your notes. So we know that the specific heat of water, H2O, is equal to 4.184 joules per gram degrees Celsius. Okay, so you can go ahead and use that information to solve that question. And then 145 sample of an unknown substance was heated from 25.0 degrees Celsius to 45 degrees Celsius with the absorption of 5,750 joules of energy. What is the specific heat of this substance? So for this one, we're going to go ahead and use that equation Cp is equal to Q over M times delta T. And then for this one, because we're asked about the heat, we're going to use Q is equal to M times C times delta T. So what I would like you to do is go ahead, pause this video, try out these 2 questions on your own, and then come back and we'll go over them together. Okay, so for this first question, I've started to fill in some of the variables already. So we know that the mass is 10.0 grams. The specific heat, we found that in our notes. And then we take the final minus the initial temperature, which is a difference of 14.1 degrees Celsius. So we go ahead and plug these values into our calculator. So 10 times 4.184 times 14.1. So we go ahead and multiply that all together. That gives us the value of 589.944. But we do need to think about sig figs. So this one has 3, this one has 4, and this one has 3. So we want to round our answer to 3 sig figs, which means I'm going to chop it off between the 2 9s and the 9s round up. Well, in order to keep the 3 sig figs, I need a 0 there. I'm going to add the decimal point so that 0 is significant. Now, if we think about our units, degrees Celsius cancel out, grams cancel out, which leaves me with joules. So the answer for that first question is 590 decimal point joules. For the second question, we take the energy, which is 5,750 joules, and then divide it by the product of the mass, which is 145 grams, and the change in temperature, which is 20 degrees Celsius. So we plug this into our calculator. 5,750 divided by 145 times 20. So that gives me a specific heat of a 1.9, and then in this case we're going to need 3 sig figs, so 1.98, and then we're going to have units of joules per gram degrees Celsius. So I hope that helps. If you have any questions with these type of calculations, please go ahead and let me know. Otherwise, have a great day, everyone. Bye.